Honda's Asimo was climbing stairs back in 2005. Unitree's robots handle them today without breaking a sweat. So why are we still calling terrain navigation a hard problem? Because stairs were never really the problem. Here's the thing. Flat warehouse floors are the robotics equivalent of training wheels. The moment you want a robot to enter a home, inspect an oil rig, or navigate a construction site, everything breaks. Think about the last time you walked through a parking garage. You didn't consciously process every curb, puddle, or piece of debris. Your body just handled it. Replicating that in a machine is brutally hard. And this is where ANYbotics in Switzerland made a different bet entirely. They said, forget humanoids. 4 legs beat 2. Their ANYmal robot has been deployed in oil and gas facilities since 2016. Not demos, not pilots, actual operations. Thousands of hours navigating metal grating, industrial stairs, confined spaces. The quadruped bet is simple. 4 legs provide inherent stability, and when a fall means expensive downtime or equipment damage, stability wins every time. But here's where it gets interesting. RobotEra in China is making the opposite bet. They're accepting the harder balance problem of 2 legs because they believe humanoid form factors will ultimately matter for human environments. Our stairs, our doorways, our tools, all designed for human bodies. Their Star 1 humanoid recently crossed mountain paths, grasslands, and gravel in China's Hexi corridor. Outdoor terrain that most humanoids can't touch. The secret is their training approach. Instead of scripting specific movements for specific obstacles, they use reinforcement learning combined with foundation model pre-training. The robot learns generalizable movement patterns. It's a bet that AI can close the stability gap with quadrupeds, and that when it does, the humanoid form factor becomes a massive advantage. Now, this is the part nobody talks about. Unitree Robotics is playing a completely different game. They sell both quadrupeds and humanoids. Their GO2W adds wheels to legs for all-terrain flexibility. But their real edge is cost. Vertical integration of motors, reducers, and controllers lets them price robots at a fraction of Western competitors. They've become the default research platform for academic labs worldwide. And here's the strategic insight. Whoever supplies the most platforms accumulates the most real-world data. Data is what trains better locomotion. Unitree isn't trying to win the hardware war. They're trying to win the data war. So, what's still missing? Nobody has cracked real-time adaptation to truly novel terrain, surfaces the robot has literally never encountered before. Current systems rely heavily on training data, show them something genuinely new, and performance degrades fast. The breakthrough everyone's chasing is a robot that reasons about terrain physics the way humans do, generalizing from first principles rather than pattern matching against past experience. Whoever solves that owns the next decade of locomotion. So, why does this matter beyond robots? 80% of work environments aren't perfectly flat. Aging infrastructure, disaster zones, the average American home with its 3 steps to the front door. Progress here determines whether robots remain expensive tools for structured factories or become genuinely useful in healthcare, elder care, and emergency response. The stairs are just the beginning.